Hi, this video will talk about how to use Gaussian elimination to achieve row-echelon form. We talked in our last video about row-echelon form. It's when we have ones on the diagonals and zeros to the left of those. As you can see in this augmented matrix, I have a 1 in my first spot, but I need a 1 here and a 1 here, and zeros here, here, and here to make this row-echelon form. And the way that I'm going to do that is by simply multiplying by constants and adding to different rows to achieve my ultimate goal. The first thing I want to do is get rid of this one here and get it to be a 0. The way I'm going to do that is to multiply the third row, this entire row, by -1. So minus R3, that's our shorthand. R3 means row 3. So I'm going to multiply -1 times R3, and then I'm going to add it to R1. Okay? So if I multiply -1 times this third row, this will become -1, -1, -2. And now I'm going to add that to row 1. And I'm going to put my result back into row 3. Alright? So I'm not going to change row 1. I'm not going to change row 2. Alright? All I'm going to do is take these numbers and add them to row 1 and stick it into row 3. So I get -1 and a +1 gives me 0. A -1 and a +1 gives me 0. A -2 and a +1 gives me a -1. And I forgot this, I got to do this side too. A -10 and a 6 gives me a -4. Okay, so that's all I did. Now, I want a 1 here, okay, not a -1. So in order to clear that out, I'm simply going to multiply the third row by -1 and put my result into R3, into the third row. Not going to do anything to the first row. It's going to stay the same. Not going to do anything to the second row. It's going to stay the same. And all I'm doing in the last row is multiplying the entire row by -1. So this -1 becomes a +1, the -4 becomes a +4. Alright? And now I've gone a long ways. I've got a 1 on my diagonal here. I've got a 1 on my diagonal here, which is what I want. I've got zeros to the left. So now I want to concentrate on clearing out this 2. I want a 0 here. The way I'm going to do that is by multiplying the first row by -2, so -2 R1, and adding it to row 2. And I'm going to put my result into row 2. So I'm not going to do anything to the third row, and I'm not going to do anything to the first row. All I'm doing is multiplying the second row by -2, and then I'm going to add that, the first row by -2. Easy for me to say. I'm going to multiply the first row by -2 and add it to the second row. Okay? So this first row is going to become -2, -2, -2, -12. And now I'm just going to add it to the second row. -2 and a +2 becomes 0. -2 and a +3 becomes 1. A -2 and a -1 becomes -3. And -12 and a +3 becomes -9. And now, if you notice, I have this in row echelon form. I have my 1s on my diagonal, and I have my 0s to the left. And so now, from here, I can set out to find the solution. I'm going to translate this back into my system of equations. Z is going to equal 4. Okay? From this, I know that y minus 3z is going to equal -9. But I can actually plug in for y, okay, for z, and solve for y. I get y minus 3 times 4 equals -9. Y minus 12 equals -9, or y equals 3. So I know that z equals 4, y equals 3, and from this first equation, I know that x plus y plus z should equal 6. So if I plug in and solve for x, I'll get x plus y, I know y is 3, plus z, I know z is 4, is going to equal 6. I get x plus 7 equals 6, or x equals a negative 1. So my solution for this is negative 1, 3, and 4. Okay? And that is how we translate an augmented matrix into row echelon form and then get the final solution.